Welcome to the Crazy Hat Chemist. So here we go again today. Another Lewis dot structure. Man, there's lots of them. Bam! Okay, the Lewis dot structure for sulfur hexafluoride. Again, this is two nonmetals. Prefix naming, the hexa, that's for 6. So 1 sulfur, 6 fluorines, SF6. We're going to count up the valence number of electrons using our periodic table right there. That's 6 for sulfur, 7 for fluorine. There are a total of 6 fluorines. We're going to sum these numbers up, and that gives us 48 total electrons. Bam! That's a lot of electrons, man! We're going to divide that by 2, though. So now I have only 24 pairs. The least electronegative element, that goes right in the center, and it's the furthest from fluorine. So it's not the fluorine, it's the sulfur. Bam, there we go on that one. Then the fluorines go around it. Now, how we space the fluorines is important in that we need to understand first that sulfur can be hypervalent. That is, it can exceed the octet rule. Sulfur can exceed the octet rule. Why? Because it's period 3 or greater. Period 3, period 4, period 5, period 6, period 7. Okay? So sulfur can exceed the octet rule. So we're going to space the fluorines around the sulfur approximately equally. Just like that. Okay? Then what we're going to do is we're going to place these 24 pairs of electrons as is appropriate. The first set of pairs of electrons in which we do are bonding pairs of electrons between the central element and the outside elements. I've done that right there. Then what we do is we place the lone pairs of electrons that remain around the outside elements. Bam! I've done that right there. I've actually used up all 24 pairs of electrons this time. So I'm going to circle and make sure that I've done this correctly. I've circled each of the fluorines. Each of the fluorines has an octet. Fluorine must have an octet. There are no exceptions to fluorine on that. The sulfur, however, I already mentioned, is hypervalent and it can exceed the octet rule. Now what we need to do is clean this Lewis dot structure up, make it look pretty, and that is bonding pairs of electrons. That is single bonds, sigma bonds, are drawn as lines. Lone pairs on the outside elements are drawn as dots still, and then we end up with this wonderful, beautiful structure of sulfur hexafluoride. I hope you enjoyed that video. I got a sparkly hat. Thank you very much, Kelly. Years and years ago, she was a great student. Kelly, thank you very much. Hopefully you are a nurse now. Have a great day, and I'll see you next time. Give me a thumbs up on that video, and subscribe to my YouTube channel, please. Bye now.